In this video, I am going to use examples to show how you can use a step-by-step method in balancing redox reaction and balancing redox equations using half reaction method in alkaline or acidic medium. This method has about 9 different steps. We are going to use 2 examples: potassium manganate 7 and potassium dichromate. Our first example in this is potassium manganate 7 that we are going to use. There are 9 methods. In these 9 methods, step number 1, in these 9 steps, the first step number 1, is you have to determine oxidation number for each atom in the equation you have been given. Step number 2 will be to use the oxidation number to determine what is oxidized and what is reduced. And step number 3 will be to write a half reaction for reduction. Step number 4 will be to write a half reaction for oxidation. Step number 5 will be to balance all the elements except hydrogen and oxygen. But if it is in an acidic medium, you will balance the oxygen using a molecule of water, and also balance the hydrogen using a proton. But if you have the base, if it is in a basic medium, you will balance the oxygen using an OH ion. After that, step number 6 will be to add up all the charges on each side. Then step number 7 will be to balance the charges by adding electrons. Step number 8 will be to multiply the half reactions by factors that will cancel out the electrons. Step number 9 will be to add the 2 half reactions back together to eliminate out intermediates. So we are going straight away to our first example, which is manganate 7. The question is, use the half reaction or half equation method to produce a balanced equation for the reaction below. We have manganate 7 plus iron 2 in acidic medium to give manganate 2 ion plus iron 3 ion and a molecule of water. From what we said, from the rules we have just read, the first step was we have to determine the oxidation number of the element of each atom there. So in that case, let me first write the equation before we do that. We have manganate here plus iron plus in that case I don't need to, let's follow the rules. Yes, plus iron to give manganate 2 plus what? Plus iron 3 ion 3 plus water. However, let me just put this as the equation indicates. Okay, this is the equation. Step number 1 will be to determine the oxidation number. Okay, here, if I want to determine the oxidation number here, if you go to our previous video, the manganese here is what? Manganese is, let me say, is X. X minus oxygen is minus 8, negative 2 times a minus 8 equals to minus 1. Manganese is plus 7 here. That one is done. So manganese is plus 7. Okay, we put it there, plus 7. That is step number 1, is plus 7. Then this one is plus 2. Now, this one too is plus 2. And this one is plus 3. Okay, let's go. Step number 2, determine which one is oxidized and which one is not oxidized. Okay, from plus 7 to plus 2, there is reduction. So we need to write an equation here, from here. This is reduction. This is a reduction that is taking place. Then from here, from this other one here, from here, this is oxidation. This is reduction and this is oxidation. Now, this is step number 2. Step number 3, we need to divide the equation into two. We need to divide the equation into 2 and write which one is oxidation and which one is reduction. All what we have done here is step number 1 and number 2. Then step number 3 is to write a redox reaction. Step 3. Step number 3, write a redox equation. Write a redox equation. A reduction equation, sorry. A reduction equation here we have. Reduction equation is from manganese to manganese 2. So what we need to do is we write the equation here. All of them are aqueous, but I don't need to be writing it now. It's a long procedure. Okay, step number 4, we need to write the oxidation equation. Oxidation equation. Okay, the oxidation equation is which one? Here we have oxidation equation to be ion 2 plus is oxidized to ion 3 plus. Okay, step number 5. Step number 5 will be to do what? Step number 5, after writing it, step number 5 will be balance all elements except hydrogen and oxygen. Now balance all the elements. Step 5. Balance all elements. All elements, or what we call atom, or let me say atoms. Balance all element atoms except hydrogen and oxygen. So in balancing all the elements, what do we do? In balancing all the elements, we start with the first equation. The first equation with manganese. The first equation with manganese, let's see how we can balance it. We have manganese 7. We are balancing it. All the atoms in order are in. There's only one atom here on this side, and there's only one atom here, so that no problem is involved in it. So let's go to ion. Ion 2. There's only one atom on one side, on the other side. So now everything is okay here. To ion 3. Then it will lead us to step to do what? Balancing. Under this, we still have to do balancing of oxygen. Balancing of oxygen still under step number 5. Balancing of oxygen. Oh. Balancing of oxygen. This is what we have. To balance the oxygen, we are going to balance oxygen in manganese 7. And how do we go about it? Balancing oxygen in manganese 7, this is what we do. Manganese 7. We were to balance all elements except hydrogen and oxygen. But remember, we are to balance oxygen. In our step, we say balance the oxygen using what? Using a molecule of water. So oxygen is on this side. We need to balance the oxygen on the left-hand side using a molecule of water. So we say plus a molecule of water. Plus water. There are four atoms of oxygen here, so there's just 2 here, so there's just 1 here, so we need to do what? We need to put a 2 here, a 4 here. We need to put a 4 there to balance the oxygen. Okay, let's go back again. We need to balance, and we need to write the equation for ion. Ion 2 again. We don't need to balance any hydrogen or any oxygen there, so we just still have to repeat it. Balancing, under balancing of oxygen, we are still going to repeat it. Ion. You have nothing to do when it comes to oxygen. So ion remains like that. Now, we see how to continue again. Under step number 5, balance. We have balanced oxygen. We need to balance hydrogen, and we need to balance hydrogen using a proton. So now, balancing hydrogen using a proton. Balancing hydrogen using a proton. So what do you do now? We need to go there again and balance the hydrogens. There. We start with manganese 7. Manganese 7 plus to give there was here on the left hand side, on the right hand side, there is a molecule, 4 moles of water that are there. 4 moles of water that are there. They contain hydrogen. So we need to balance the hydrogen on this side. So what do? We need to balance the using what? A proton. So we need to add a proton here to balance the hydrogen. And how many hydrogens are here? We have 2 times 4, 8. So automatically there are supposed to be 8 protons that are there. So we put our 8 here. There are 8 protons that are there. Now we have to continue again to add ion 2, even though it has nothing to do with balancing hydrogen there. Ion 2, you still have to continue to have to ion 3. Okay, now step number 6. Add up all the charges. We need to add up all the charges. Okay, step number 6. Add up all the charges. Step 6. We need to add up all the charges. Then, step number 7. In step number 7, we need to balance the charges by adding electrons. Balance the charges by adding electrons. So let's start straight away with a manganese 7. Let's start straight away with manganese 7 and start adding our charges there. So now, with manganese 7, we have we don't know this, we don't know what we hear. We need to add the charges. Let me write there so that you know how you can do it. Okay. Manganese 7 to give manganese 2 plus 4 moles of water. Then now, ion is here, ion. Yeah, to give ion 3 plus. Now we need to add all the charges. Step number 6. Let's see how we can demonstrate it here. In step number 6, what do we do? In step number 6, this is what is happening in step number 6. Here we have manganese. We have a negative sign here, a negative charge here, and there is a positive charge here. So there are 8 positive charges that are here. Then plus this negative charge, a negative 1 plus 8 plus 8 is what? Is negative 1 plus 8 is plus 7. On this side we have plus 7. Okay, now let's go on the right hand side. Adding all the charges there, we have only 2 plus, a 2 plus. On the right hand side, we have 2 plus. On the left hand side, we have 7 plus. So what must we do here? How many number of electrons can we add on the left hand side so that it can balance the charge on the right hand side? Okay, plus 7, we have electrons are negatively charged. So when we add electrons that are negatively charged to a positive, it's going to reduce the positive charge. So we have plus 7 here. This plus 7. Plus 7 plus, how many electrons will give us 2? It will be 5 electrons. It will be 5 electrons. 5 electrons, when added to plus 7 and plus 7 here, will give us plus 2. The plus 2 will be equal to the plus 2 on this side. So we have balanced the charge by adding electrons here. There's plus 2 here and there's plus 2 here. When we add the electrons and the plus 7 is plus 2, and plus will be equal to the plus 2 on the right. Okay, let's go to ion here. Ion from plus 2 to plus 3. What must we do to maintain the plus 2 on both sides? Okay, there's plus 2 here. We cannot add electron here. If we add electron here, it's going to reduce this charge again. So it's better we add here. So we add an electron here. Electrons are negatively charged. They have a negative charge. So now when we add it, it's going to reduce the positive charge here. So how many electrons can we add here that will reduce to plus 2? It will be plus electron. It's just 1 electron. Only 1 electron is needed. 1 electron is a negative charge. A negative charge plus 3 plus is, now it would go to 2 plus. So now it's only 1 electron that is needed here. Now it leads on now to what? To step number 8. Step number 8 says we have to multiply the half equations by factors that can cancel out the electrons. Okay, step number 8. Step number 8. Step number 8. Step number 8. Multiply half equation by factors to cancel out the electrons. Multiply half equation equations by factors. To what? To cancel out the electron. To cancel out the electrons. Okay. Now, okay, to do this, okay, what are the factors? This is this equation here and this other half equation here. To balance the number of electrons on each of the equation, we need to multiply this one by 1 and multiply this number of electrons here by 5, so that the 5 electrons in the manganese will cancel the 5 electrons in iron. So in that case, we need to do the multiplication. Let's go back again. Iron So we need to multiply it. Let's multiply this. We will multiply this by 1, by a factor of 1, and multiply this other equation by a factor of 5. When we do that, when we multiply this, what we are going to have will be this. When we do that, what we are going to have in this equation will be we are going to have manganate. Manganate will not change. Manganate 4 would, manganate 7 will not change. It won't change. Okay, for iron will change. We will have, for iron, we are going to have, there is iron here, iron 2 plus, to give iron 3 plus, plus electrons. So now let me change the electrons for you to see properly. Here, this iron is going to be 5. Iron is going to be 5. 5 plus how many electrons? Plus 5 electrons. Plus 5 electrons. Now we need to cancel out. We need to cancel out the electrons. We need to cancel out the electrons. What we need to do now is to cancel out these electrons we have multiplied the factors by. We have to this one, we have to cancel this, and we have to cancel this one. So this electron will cancel. We will cancel this one. We will cancel this one. In that case, it leads us to step number 9. Step number 9 will be add the two equations, and the two equations will give you your final answer. Step number 9 will be step number 9. Add the two equations. The two half equations, sorry. Add the two half equations. If we add up the two half equations, what we are going to have will be, if we add up the two half equation, what we are going to have will be, we will have If we add this two half equation, we are going to have manganese. There is the manganese from here, plus 8 protons, plus these 5 ions, ion 2, to give us manganese 2, plus 5 ions, plus 5, 5 ion 3, and plus 4 moles of water. That will be our equation. That will be our final equation. That will be our final equation. So our final equation now will be this one, please. That will be our final answer. So, a recap. This is a procedure in balancing redox equation using half reaction method in acidic medium. Many examples, you can do many other examples with potassium dichromate and many other examples. Here we have just treated reaction of ion, potassium manganate 7 with ion 2 to in an acidic medium. So this is how you can balance your equation. You take the steps. Know that you have to write, first of all, write, if the equation is not given, you need to write the full equation. From the full equation, you need to determine, step number 1, you need to determine which the oxidation numbers. And based on the oxidation numbers, you will know which of the atom or which of the element is being reduced and which one is being oxidized. We did that here, and we saw manganese was being reduced and iron was being oxidized. Then it goes to step number 3, which we have to write the half equations of reduction, and we did that one. Half equation for oxidation, we did that one. Half equation. Then we need to balance the elements or the atoms except the hydrogen and the oxygen. We did that one. Then we balance the oxygen using a molecule of water. We balance the hydrogen using a proton. And in that one, then we added up all the charges in step number 6. Step number 7, balance the charges by adding electrons. We added all the electrons, and we saw that the electrons were not equal on the two half equations. So it drove us to step number 8, multiplying half equation by factors to cancel out the electrons. So we did the multiplication of the first equation, reduction equation, by 1, a factor of 1, and the oxidation equation by a factor of 5, and we cancel out the electrons. And finally, we went to step number 9, which was to add the two half equations. And when we added all the two half equations, this was our result. So that is how you balance. That's how you can write a full redox equation using half reaction method in acidic medium. Next time we will treat in alkaline medium. Thank you. Thank you. You share this to fellow learners and subscribe.